rod of 160 mm diameter at 315 RPM, 2.5 mm depth of cut, and a feed of 0.16 mm per revolution by a tool of geometry 0, 10, 8, 9, 15, 75, 10 mm. The following observations were made. The tangential component of the cutting force, the axial component of cutting force is given, chip thickness is given, and he is asking us to draw the merchant circle diagram and to calculate all the forces. So here already two type of forces are given. Okay. Here already two type of forces are given. What are those two forces? Anyone? What are those two forces? See this, anytime you see in the question that it is written tangential component of cutting force, tangential component of that cutting force is nothing but FC, F cutting. Tangential component and epsilon code is FCA. Because you see in the diagrams that we have drawn earlier, so always the cutting force is always tangential. So this workpiece to the workpiece, this cutting force is always tangential. Okay, this is a circular workpiece, no? A cylindrical workpiece. So this tangential force, if any time you see tangential force written in the question, to consider that the tangential force means is a cutting force. Now, what is this axial component of cutting force? Tangential component of cutting force means it is the FC. Now, what is the axial component of cutting force? Quickly tell me.
Thrust force, sir.
Not thrust force. I know that you will say that it is thrust force, but it is not thrust force. Why? I will tell you. See. This is the top view of the tool. Everyone observe, please. So what we had is, we had one force in this direction. We had another force in this direction. And we have the resultant of these two forces. So this force was the feed force, which is FF. This force was the thrust force, which is the resultant of the feed force, and this is the radial force. And this angle was how much? How much? Tell me. Psi s. So here it is said that this is the axial component of the cutting force. So here axial component is what? Tell me. Which component is along the axis of the workpiece? Where workpiece will be? Workpiece will be somewhere here. Like this. Like this workpiece will be there, na? Workpiece will be there like this. So what is the axis of the workpiece? This is the axis of the workpiece. So which force is along the axis of the workpiece? Which force is along the axis of the workpiece? Feed force is there, na? This feed force is along the axis of the workpiece. So here it is said the axial component of the cutting force. Here it is said that it is axial component of the cutting force. So this axial component of cutting force is nothing but the feed force only. It is not the thrust force. So from this feed force, we have to calculate the thrust force. And how can we calculate it? We need to know the value of the side cutting edge angle. And that side cutting edge angle value we can get from this tool signature. Are you following? Yes or no?
Yes, sir.
No, only you are saying yes. What about others? Asha, Kiran, Sheikh, Nayak, Santoshi, VV, SS, Siddhartha, Manikanta. All of you are following. So you should let me know that you are following. In between, keep texting. Yes, yes, yes. Okay. Now the next is the chip thickness. So what is the meaning of chip thickness? Chip thickness means This is the value T2. Okay. And what value can I take as T1? Tell me. What value can I take as T1?
Depth of cut 2.5 mm, sir.
Depth of cut should we take, or what should we take? Anything else? Yes. I will go back to the previous classes. Here you see, this derivation we have already done. Here we have one formula that T1, which is uncut chip thickness, is F cos psi s. Okay, so here, if feed and side cutting edge angle is known, then you have to calculate the uncut chip thickness with the formula T1 equal to F cos psi s. Okay, if psi s is not given, then you will assume that the cutting is an orthogonal cutting and psi s will be automatically 0. So you will take T1 equal to F, because that is T1 equal to F cos 0. Okay. And if neither side cutting edge angle is given nor feed is given, in that case you will take depth of cut as the, you will assume depth of cut as the feed. Depth of cut is never equal to feed actually. But in the question, if no other data is given, and if you have to calculate the ratio of T1 upon T2, then you will assume that the chip thickness is equal, the uncut chip thickness is equal to the depth of cut. But in this particular case, we have the value of psi s, we have the value of feed, so that's why we will calculate our uncut chip thickness as F cos psi s. Okay. Are you following? If you want me to repeat it, I will repeat it, not a problem. This is the formula. This is something that we have derived long ago. Long ago. Take the screenshot. And now here I will write what is the given data. Given data. Can anyone tell me what is the value of FC? Quickly tell me. By looking at the question, I'm not going to change it. Tell me quickly, what is the value of FC? 500 Newton. What is the value of FF? What is the value of FF? 200 Newton. Now, if I want to calculate the thrust force, just if I want to calculate the thrust force, this is the top view of my tool. This is the feed force. This is the radial force. And the resultant of these two forces is the thrust force. This is FT. This is FF. And this is FR. And I want, this is psi s. Now, what will be the value of, what is the relation between FT and FF? So, FF will be equals to FT cos psi s. Right? Now, what will be the value of FT? FT equals to FF upon cos psi s. What is its value? Tell me. Just a minute. What is the value of Psi S, tell me. Everyone should tell me the value of psi S. You see the tool signature and tell me the value of psi S. See the tool signature. 8 degrees. I'm asking cutting edge angle. You are telling me relief angle. Manikanta is saying it is 75. Okay. Others, quickly tell me what is the value of psi S? Side cutting edge angle. Immediately tell me. I want to see how intelligent you are and how carefully you follow my classes. Janvi, how did it come as 15? How did it come at 15? Tell me, Janvi, how did you said it is 15? Very good. Very good. This is ORS tool signature. Very good, Janvi. Because you see this angle is how much it is. I told you one technique to check whether the given tool signature is ASA tool signature and ORS tool signature. This angle, if it is less than 35 degrees, then it is what? Side cutting edge angle. But if it is more than 35 degrees and less than 90 degrees, then it is lambda, which is the principal cutting edge angle. So this is lambda actually. So you have to calculate this into psi S. How can you do that? You have to do that as lambda is given as 75. So psi S you have to calculate as 90 minus 75, which equals to 15. Right? So here to calculate FT, what you have to do? You have to write it as FT upon cos 15. And if you are writing as lambda only, then you have to write sine 75. So 200 upon cos 15. How much you are getting? Quickly you have to tell. Bring the calculators. 205. 200 divided by cos 15. Just a minute, let me check. Do it properly. I am getting it as 207.055. 207.055 newtons. Okay, so I got the value of FT. I got the value of FC. Good. Now what I will do is, I need to calculate all the angles with the help of the merchant circle. So I already calculated FC, which is given in the question. I already got the value of FC. I got the value of FT. Okay. Now what else in the merchant circle I require? First I will draw the merchant circle. Then you will get to know. Today you will understand how easy merchant circle analysis is. Dead easy. Up to this point, anyone having any doubt? Here we have the tool. Okay. This is FC. This is FT. This is resultant. This is friction force. This is normal to friction force. This is shear force. This is normal to shear force. This is FT, FC. This is FT. This is resultant. This is friction force, normal to friction force. This is 90 degrees. This is 90 degrees. This is shear angle phi. What is this? Fs. Fs direction is here, normal direction. Draw the directions also. What is this one? normal to shear. Okay, this is what we have done so far. No? This is the tool. Okay. So what was this angle? This angle was beta. This angle by how much? Tell me. This angle was alpha naught. So this angle will be also alpha naught. So this is 90 minus beta. So this angle will be beta minus alpha naught. Clear up to here or not? Clear up to here or not? Clear? Chappande? Yes. Okay. So you know the value of FC. You know the value of FT. So can you calculate the value of resultant? You know the value of FC, you know the value of FC. So resultant R will be how much? Root over of FC square plus FT square. Clear? So R equals to root over of how much is FC? FC is 500 plus FT is how much? 207.055. Calculate and tell me how much you are getting. R is the resultant. Tell me how much is R? $541.176 newtons. This is the resultant. So this also you haven't got. The resultant also you have got. Okay. Next. Can you tell me how can I calculate phi? Phi is the shear angle. You know the formula of phi as tan inverse of R cos alpha naught by 1 minus R sin alpha naught. This you know. Right? This formula you have already derived. So you see here from the tool signature, can you tell me what is alpha naught? From the tool signature, can you tell me what is alpha naught? $10 degrees. This is alpha naught. Very good. So you know the value of alpha naught. Here you know the value of alpha naught. Alpha naught equal to 10 degrees. Now what is the value of R? R is equals to T1 by T2, where T1 is the uncut chip thickness and T2 is the chip thickness. In the question itself, chip thickness value is given to you as 0.48 mm. It is already given to you as chip thickness value is always given to you as 0.48 mm. Now uncut chip thickness value, how can you calculate? Uncut chip thickness, how can you calculate? .48 divided by, I have already told you the formula, that is feed multiplied by cos psi s. Okay. If feed and side cutting edge angle both are given, then you should use this formula. If only feed is given, you will assume that psi s is equals to 0. So cos 0 equal to 1. So uncut chip thickness is equal to the feed. If neither feed is given nor cos psi s is given, then you will take depth of cut. You will assume depth of cut as the uncut chip thickness. So if you do this, how much is the feed? Feed is how much? 0.16. So 0.16 multiplied by cos 15, right? Divided by 0.48. Calculate and tell me how much you are getting R. How much you are getting R? What is the value of R? Zero point 3219. Very good. Now, can you calculate phi tan inverse R cos alpha naught divided by 1 minus R sine alpha naught? Can you calculate this? Phi equals to tan inverse R is how much? 0.3219 cos 10 divided by 1 minus 0.3219 sine 10. How much is phi? How much is phi? $18.56. Good. So from this merchant circle, now everyone observe, those who have calculated, let it be, those who haven't calculated, observe here. Everyone observe here. You know the value of a resultant, okay? And you know the value of phi. Okay. Just a minute. You know the value of resultant. You know the value of FC. You know the value of alpha. Can you calculate the value of beta? See, we have derived so many formulas. Na? All those formulas are only for the exam purpose. In the exam, if they ask you to derive the formulas, then only you have to derive. But there is no point of remembering those formulas which we have derived for the merchant circle. Merchant circle is all about simple trigonometry and geometry. If you know fundamentals of trigonometry, if you know a little bit of geometry, then you can easily solve any problem which is asked to you, which is related to the merchant circle. Here, you see that FC is given. FC you already know. Resultant you have already calculated. Alpha you already know. Then you can calculate beta also. How can you calculate beta? So in this triangle, if you apply cos theta, cos beta minus alpha naught, how much you will get? Cos beta minus alpha naught will be FC upon R, right? Yes or no? Yes, very good. So what am I doing is cos beta minus alpha naught equals to FC, that is base, upon hypotenuse, that is R. Can I do it like this? Now beta will be equals to cos inverse of FC upon R plus alpha naught. Can I do like this? Anyone having any doubt? How did I do like this? No. So you calculate and tell me what is the value of beta. Asha Kiran, are you not there in class today? $32.49 degrees. Very good. 32 point. Good. So you have got this value also. You have got beta value also, and you have got alpha naught value also. So now you tell me, if I want to calculate the shear force, I know the value of Fs. I don't know the value of Fs, but I know the value of resultant. So in this triangle, if I apply cos theta, can I calculate easily the value of Fs? Say yes or no. cos phi plus beta minus alpha naught. See, phi plus beta minus alpha naught. The overall angle will be phi plus beta minus alpha naught. So cos phi plus beta minus alpha naught equals to Fs by R. Equals to Fs by R. Yes or no? So what will be the value of my shear force? R cos phi plus beta minus alpha naught. Fs equals to R is how much? How much is the value of R? 541.176 cos. How much is the value of phi? Beta is 32.49. Alpha is 10. And how much is phi? 18.56. 18. Now can we tell me the value of Fs? What will be my Fs? 408.09. Okay. 408.09. Very good. So we have calculated Fs. Now can you calculate normal to Fs? Can you calculate normal to Fs? You can easily calculate normal to Fs. All you have to do is you have to take sine phi plus beta minus alpha naught in the triangle, and you will get how much? And normal to shear by R. So what is the value of normal to shear? R into sine phi plus beta minus alpha naught. Tell me the value of Ns. Tell me the value of Ns. $355.399. I am not checking. Whatever answers you are telling, I am writing. 355.399 newtons. Good. Okay. Now I will tell you to calculate something else. Now you can do it on your own. You don't require my assistance. I got it. Now you tell me, can you calculate friction force? Can you calculate friction force? You already know the value of resultant. You know the angle beta. So what you have to do? You have to apply sine theta. F by R equals to sine beta. So you can easily calculate the value of F. N by R equals to cos beta. Calculate and tell me what is the value of friction force and normal to friction force. I am writing sine beta cos beta. Sine beta will be F by R. F by R. Cos beta will be N by R. So F equals to R sine beta, N equals to R cos beta. Okay. F, Janvi is telling us 290.69 newtons, and normal is how much? 456.47 newtons. Okay. So anything else is there which we have to calculate? Everything you have calculated, right? All the forces you have calculated. But at the end, if I give you one task to tell me what is the value of coefficient of friction mu? What is the value of coefficient of friction mu? What is the value of coefficient of friction mu? What is the value of coefficient of friction? How did you calculate it, Tejasvi? Tan beta. And you will get it as 0.6368. You have done it as F by N. straight away you can take it as 10 beta also, because beta angle you have already calculated, and 10 beta is nothing but coefficient of friction. Okay, so many methods are there. You can do it by F by N also, not a problem. All will get you the same result. So this is how you are going to calculate if any problem comes in the exam related to the merchant circle. And I feel that after I have taught you merchant circle, in the question in the exam, if question comes from merchant circle, you are not going to leave that question. Means if a problem is given and if a theory question is given, you will more likely to attempt the problem only than the theory bit, right? Because you have so much of hands-on experience in solving these problems. I will, if time permits, anyways, I will be taking the Friday afternoon class also. So if time permits, I have many problems with me actually, many different varieties of problems, but all the problems we can't solve in the class because of the time constraint. Already we have to complete our first unit by today, today as in this week. So I can't solve all the problems, but some good problems I will be solving, and in assignment also I will give you a few problems. Okay, so whatever question that you have solved now, this is previous year GATE question. Okay, this question is asked in GATE exam. So in the GATE questions, you might be thinking that, sir, why in GATE exam these many values are not given to find out. In GATE only one 4 multiple choice questions will be there, and only one answer I have to tick mark. But this is the time when GATE exam was descriptive, and there used to be questions of 5 marks. You need to solve the question on an answer sheet long back. So that is a 5 marks question. Okay, shall we move further? The next topic is energy, machining energy. So when you are doing the machining operation, this is the tool. This is the shear plane. This is IS, and this is the rake angle. So if 100 joules is my overall energy, total cutting energy, the total cutting energy I am supplying is 100 joules. That is the total cutting energy. Okay, so if this is my total cutting energy, then in the machining zone, where and how much this cutting energy will be utilized. So there will be 2 places where my cutting energy will be utilized. One in this shear plane, Okay. And another one where my cutting energy will be utilized will be in overcoming the friction between the chip tool interface. Here, there will be two places where my cutting energy will be utilized. So how much, if 100 joules, or if I say 100%, I would say if 100% is my total cutting energy, then out of this, around 70% is utilized in the shear zone, and 30% is utilized in the overcoming of friction between the tool chip interface. So what is the formula for machining energy? Okay. Cutting energy. Okay. So what is the formula of cutting energy? Can anyone tell me what is the meaning of energy? Work done per time? Say yes or no. Yes. Okay. Cutting energy is equals to cutting force multiplied by cutting velocity. Okay. So this will be how much? Newton. Velocity will be how much? Mm divided by second. Okay. Newton into mm, that is the force into displacement. That is the work done divided by second, which is nothing but time. So basically you are getting the unit as energy only. So that's why the formula for cutting energy is Fc into V. Okay. That is the cutting force multiplied by cutting velocity. So if I want to write the total cutting energy, that is equals to the energy utilized in shearing, means energy utilized in this green section plus energy utilized in this maroon section, right? So total shear energy plus total friction energy. Total energy, shear energy, and total friction energy. So how was the total cutting energy? Cutting velocity multiplied by cutting force. Fc into V. How much is the total shear energy? Shear force into shear velocity, right? You know the difference between shear velocity and chip flow velocity. Plus, what is the total friction energy? That is friction force multiplied by Vc. Vc is the chip flow velocity. So this is the final expression for the cutting energy. Or cutting power also. Is it clear up to here? Is it clear up to here? Okay. Yes, good, very good. So we will continue tomorrow. Okay. Asha Kiran, you have not given any answers in today's class. I was observing Janvi gave most of the answers, Sheikh gave, Manikanta, Tejasvi, but you didn't give any answers. Why?